Acids and bases. What is a buffer, and how does it work?
Now, what is pH? Buffers are used to keep pH at a constant value.
Materials. pH electrode, pH buffer 4, pH buffer 7, acetic acid, sodium hydroxide, hydrochloric acid, distilled water, and the unknowns, in this case apple juice and orange juice.
Start by calibrating the pH meter. Unscrew the electrode from the storage solution and rinse with distilled water over the waste beaker. Begin calibrating by selecting the sensors menu and then pressing calibrate. Press calibrate now and type in the pH of the first solution. In this instance we used pH 4 buffer. Stick the probe into the solution and wait for the voltage to stabilize, then press keep on the meter screen. Once stabilized, remove the probe and rinse with distilled water. Rinse between every solution and replace probe into a beaker containing distilled water when the meter is not in use. Continue by placing the probe into the second solution, pH 7 buffer in this instance. Input this number then press OK and wait until the voltage stabilizes once again. Once it's stabilized, press keep on the meter and then press OK to finish the calibration. Upon calibrating the meter with the two buffers, place the probe back into one of the buffers to ensure that it is in fact calibrated correctly. We placed ours back into the pH 7 buffer and found that our meter was in fact calibrated correctly.
The next part of the experiment is to measure the pH of several different solutions given earlier. First rinse the probe with distilled water, then place the probe in the solution that you wish to find the pH of. We did this for all of our solutions including acetic acid, hydrochloric acid, sodium hydroxide, apple juice, and orange juice. We recorded our measurements in tables drawn in our lab manuals. It takes time for the meter to stabilize and reach the accurate pH value, so we had to be patient with each solution before recording the results. Kristine completed the calibration first, followed by Michelle, Jason, and lastly Derrick. The rest of this video is essentially the same thing done over and over again up until the end when Derrick's turn comes up and the cleanup process is explained, but for now, I'm just gonna shut up until then. So peace out, Girl Scout.
Began record.
Okay. So that's about.
Have you calibrated already?
That's what I'm doing now. I think. I don't know what I'm doing.
You rinse it, after you take it out.
Where is sensors? Which one is that?
Top it says sensors.
Okay.
And then hit calibrate. And then stick it into pH 7. The pH 7 buffer.
Which one's that? Oh.
And then put in 7.
Do you have to do the 0.0?
I just did. I put in the pH 4, and then you put 4.0 or 4.00, and hit keep. Hit OK. Are you resting it on anything?
Don't
You
touch
don't
the.
anything.
Going down, sit up.
I think you may do it again.
Oh well. I don't know.
I think you may do it again.
Nah, I'm fine with it. I don't.
Because you shouldn't touch anything.
Pardon, we're just gonna go with it.
So XCO.
Oh, you
I
like?
guess we can start. I'm gonna. They're both
do
25 milliliter.
the citric acid. We'll go with the opposite end.
25 milliliters of like HCl.
Get the
one,
string.
25 milliliters
Yeah.
of acetic acid in the other.
God.
What?
Oh man, this would eat through you.
For cleanup at the end of lab, rinse the probe with the distilled water before placing back into storage solution and screwing the cap back on tightly. Properly store the meter by returning it to where you obtained it. Wash any used glassware, dry them, and store them properly before surveying your workspace to ensure everything has been cleaned and put away.
These are our lab results for the experiments completed. In conclusion, what are the differences between strong and weak acids?